Before wheat can be milled, it must be prepared for milling by blending and conditioning. In this chapter, you will learn about the reasons for conditioning and how various wheats are conditioned. Reasons for conditioning. Wheat is conditioned by dampening the wheat and then leaving it in bins until it is ready for milling. Wheat is conditioned to help achieve a target moisture in the flour, soften or mellow the wheat to assist grinding, and improve the separation of the anatomical parts of the wheat kernels during milling. Wheat kernels consist of three parts: the bran, germ, and endosperm. Bran is the outer covering of the kernel. It represents 10 to 17% of the kernel. Endosperm is the inner white part of the kernel that becomes flour. It represents 82 to 86% of the kernel. The germ is the embryo of the seed, the part that grows into the plant. It represents 2 to 3% of the kernel. It is mostly collected in the bran, although some mills collected some of this as a separate mill stream. The conditioning process affects these anatomical parts in different ways. Dry bran fractures into small pieces when milled, much like a dry leaf fractures into small pieces when crushed. Moistening bran makes it more like a green leaf, less likely to fracture when milled. It is therefore more likely to hold together in larger pieces during milling. This makes it easier to separate the bran from the flour in the milling process. Minimizing bran fracturing will result in less bran contamination in the flour. Bran contamination can be measured by color differences or with a test called the ash test. Low ash results suggest low bran contamination. Moistening the endosperm helps to soften it for grinding. This makes grinding more energy efficient. It also helps to achieve target flour moistures. It is in the miller's interest to produce flour with moisture as high as the customer will allow. By adding water during conditioning, the miller is effectively selling water in the flour. However, high moisture can also reduce shelf life, so customers usually have an upper moisture limit. Very high moisture can reduce the flour extraction rate, which can influence profitability. How various wheats are conditioned. Dampening targets for various wheats depend on their hardness. Softer wheat may be dampened to as low as 14% moisture, while harder wheat may be dampened to as high as 18% moisture. Harder wheats require these high moisture targets to achieve the same level of mellowness. Harder wheats are also more resistant to moisture penetration and so require longer tempering times. Soft wheat may be tempered for as little as 6 hours, while hard wheat may be tempered for 24 to as long as 72 hours. Since different wheat types need different dampening targets and tempering times, it is often better to condition these different wheat types separately. This allows optimum tempering times to be achieved for each wheat, rather than blending wheats and applying an average of the optimal settings. Some mills have multiple conditioning lines so that multiple wheat types can be conditioned simultaneously with the necessary variations in conditioning targets and times. Tempering bins are designed to allow different tempering times. Dampening happens continuously. The wheat is fed into a tempering bin continuously, and tempered wheat is drawn from the bins continuously. The tempering feed rate is fixed to that of the mill feed rate, and the mill feed rate is fixed according to the capacity of the plant. Since the tempering feed rate is fixed, tempering times are not controlled by feed rates but by bin space. The more bin space used, the longer the tempering time. The tempering bins need to be sized to allow the maximum required tempering time for the wheat being milled. Bin space can also be increased by running through multiple tempering bins. Optimum tempering requires every kernel to take the same amount of time to pass through the bin. This is called laminar flow, or first in, first out flow, or FIFO flow. Bins with a single outlet cannot achieve this, because grain at the centre empties faster than at the sides. Therefore, tempering bins have multiple outlets or other outlet designs to allow this. Dampening targets can range from 14% to 18%. The moisture content of wheat deliveries arriving at the mill can vary significantly. Dry wheat moistures may range from 7% to 13%. Therefore, some wheats will require significantly more water than others to achieve the same target moisture. Dampeners mix water and wheat and attempt to cause the water to absorb into the kernels. It is normal for some of the unabsorbed water to be present on the surface of the kernels leaving the dampeners. This is usually absorbed into the kernels while tempering in the bin. However, where the moisture content of the grain needs to be increased by 4% or more, it becomes more likely that some of the water will fail to penetrate into the kernels. This not only prevents the achievement of the target moisture, but it also causes problems such as free water dribbling down through the mass of wheat and seeping out of the bottom of the bin. Wet wheat does not flow freely and tends to cause blockages, chokes, and lengthy unplanned downtime. Well-tempered wheat flows freely. To ensure complete water absorption, mills tend to add water in 2 or more stages. Typically, most of the water is added in the first stage and tempered for about 2/3 of the total tempering time. The last 1 or 2% is added in the second stage. Some mills have a final dampening stage called a pre-dampening, where up to 0.5% moisture is added to 15 to 20 minutes before milling. There are various types of dampeners to mix the water into the grain. These include incline screw conveyors with discontinuous flights. Water is added at the base and mixes with dry wheat as it is conveyed upwards. Intensive dampeners and tri-star dampeners mix grain and water using beaters. The vigorous action is claimed to reduce surface tension and so improve absorption. Most dampeners will come supplied with a system for controlling water flow. There will be a system measuring the critical parameters of the incoming dry wheat, and sometimes the tempered wheat. Critical parameters include the wheat flow rate, wheat moisture, and wheat temperature. This data is used to calculate the flow rate of water to inject into the dampeners. As these parameters vary, the system will adjust the water flow rate to ensure that the dampened wheat moisture remains consistent. Some systems also monitor the moisture content of the final flour and incorporate this into the calculations. Wheat is usually cleaned before being conditioned. However, since microbes multiply in damp conditions, the tempered wheat is usually re-scoured before milling. This chapter has covered wheat conditioning, the reasons for conditioning, and how various wheats are conditioned. The quiz that follows will help you to confirm your knowledge.